This is the brief on the vector cross product. Okay, so what exactly is this all about? Well, it's about connecting the math, the tensor definition of the cross product, to its fundamental geometry. It's how this one essential operation really defines direction for us in three-dimensional space. First up, the algebraic definition. The vector cross product is formally defined using something called the Levi-Civita tensor. Now, this tensor is really just a super efficient way to spell out the rules for how the parts of your two starting vectors combine to create the components of your final vector. Second, let's talk geometry. This is really important. The cross product is an operation that's unique to three dimensions. The vector you get at the end, it's always going to be perpendicular to the two you started with, and its direction is set by a simple convention we all learn, the good old right-hand rule. Finally, we have the essential identities for unit vectors. It's pretty straightforward. If you cross the first unit vector with the second, you get the third. It follows a consistent cycle like that. But, and this is key, if you cross any unit vector with itself, the result is always zero. No exceptions. So, the cross product connects that algebraic structure, defined by tensors, directly to predictable 3D geometric outcomes like perpendicularity and direction.